Amazing. Cool. Again, good night from Spain to everyone. My name is Ubiratan. I'm not Spanish. I am Brazilian, but I live here in Spain. Today, I'm going to talk with you about Gradle builds, not only Android builds, but mainly about Android builds. I will talk about a tool called Gradle Profiler and something more, so bear with me. Maybe I don't have too much time to answer questions here in the session, but we have the Slack channel that you can use to drop me all the questions that eventually you have. It's a pleasure to be here today, engaging with Android Summit. Really, really happy to be here. So yes, let's start. First, mandatory slide. We know how these things work. Nah? I work for a company called N26. It's an European fintech, pretty much mobile bank account and so on. We have a product and a business not only here in Europe, but also in the United States. We have lots of open positions, so feel free to visit our website and eventually learn about what we are doing here in our team. So amazing. Let's talk about our problem, right? The motivation behind this talk is pretty much this very iconical comic here. The compiling problem, right? Compile times and eventually build times are so huge that we need to figure out what we can do during our Gradle build. And this is kind of reality nowadays for several Android projects, because it's just too easy to have a really, really big project with several dozens or eventually hundreds of modules living in some kind of monorepo, something like that, with dozens and eventually hundreds of developers working in the same code base. So yes, compile times and build times in general are a problem that we have so many people working this problem nowadays that I am just a humble engineer trying to do my best to understand how to survive. So yes, everyone has kind of opinions and eventually solutions on how to tackle this kind of problem. But in the end, I have with me this quote. I don't know who said this in the past, but this is something that really this is really strong for me. We can't improve what we can't measure, right? So if you want to improve things, we need to start to measure things. But not only that, we also need to make sense of the data that we are capturing, and effectively, we need to make sense of what we are measuring. And yes, fortunately, we have a guidance on how to do this. I have here this frame from a talk from DroidCon from 2 years ago. And the Gradle engineer here highlights the hashtag science, right? Here in this talk, he was describing pretty much a methodology on how one eventually can seek and resolve bottlenecks in a Gradle build, right? A bottleneck eventually driven by some plugin misconfigured, some kind of memory leak in the build, something like that, right? A methodology driven by science, right? So science is a good tool to allow us to make the most of the data that we have in our hands. So yes, probably we should hear the science, right? I mean, yeah, I would do kind of joke here, but I need kind of to be polite. Yes, let's stick with the science and let's learn how we can apply science to our Gradle builds. we need to start from somewhere, and this place is how do we measure, right? We have basically two ways to measure Gradle builds. I will stick with Gradle builds here in our examples. One way is pretty much the build scans, right? This is a feature that is delivered by Gradle, and in order to make the most of this feature, eventually the team has to have access to Gradle Enterprise, because one will have the historical data related to builds on Gradle Enterprise, and the team will have dashboards, I don't know, all sort of stuff that I never managed to get access because I never had Gradle Enterprise on any of my projects. And why is that? Because eventually Gradle Enterprise is not for all teams. Gradle Enterprise is an awesome tool, but it's also an expensive tool. And yes, eventually you have just a small team, let's say 50 engineers, 20 engineers, something like that. And eventually the team can't afford the solution. So yes, luckily we have another option. And this other option is also driven by Gradle. And this option is called Gradle Profiler. Here we have the open source repo. So yes, it's a tool that we can use to both benchmark and profile Gradle builds, right? Just to make a point here, in this talk, we will talk about benchmarking. We won't talk about profiling, right? Benchmarking is pretty much benchmarking consists into run the same task, the same Gradle task over and over, right? Pretty much in a stress way, so to speak, and pretty much capture the results and make sense of the results. Profiling is different. Profiling is more related kind of to incrementally test scenarios, right? Gradle Profiler is a very versatile tool. It can kind of support multiple profilers when doing the profiler, and such profilers can be eventually UKit, the Chrome profiler itself. It can instrument the build using the Gradle tooling API. You can control the Gradle daemon. You can define scenarios. You can do a lot of stuff, right? Gradle Profiler is not a complex tool to use. This is the fact. Because let's see how we can use this tool. First, we need to install, right? So nowadays it's quite easy. We can install directly using the SDK man tool, right? We just need to figure out the version we want and install directly from the command line. And we also have this tool available from Homebrew, which make the installation quite straightforward, both for macOS and Linux users. So yeah, quite easy to install Gradle Profiler. And let's see how we can do some kind of benchmarking. Basically, we will invoke the tool from the CLI and pass a bunch of parameters. Here, I am passing the name of the task that the benchmark will run, in this case, build. I am passing the path of my project, of my Gradle project. I am defining an output directory to allow Gradle Profiler write the results. I am defining that I will run the benchmark for 10 iterations, but before these 10 iterations, I will run 2 builds pretty much like a warm-up, which means that these 2 builds will be the opportunity that Gradle will have kind of to resolve all the project dependencies, set up all the caches and everything, right? And have a warm demo. Amazing, that's it. By running this kind of big command that we can split in some lines, we have a benchmark for a Gradle task. So this task will run 10 times and we will have the results. But not only. With Gradle Profiler, we can define some scenarios, both for the profiling and for the benchmarking of tasks, using a type-safe language called Hokun. This type-safe language is was developed by the guys from Scala World. Yes, it's pretty much like a type-safe JSON, so to speak. So if you know JSON, you know this more or less, but we can see that we don't have all the double quotes everywhere and so on. Yeah, so quite a fancy markup language, we can say. And here I am describing two scenarios that eventually I will save in a particular file. I have the scenario for the debug APK task and for the text task. For the first one, I am saying that I am doing some cleanup before every build, and I am running this task in offline mode. For the second one, I am not actually clean up any task, but I am not building on top of the Gradle build cache, right? So I can pretty much instrument my benchmarking using this kind of scenario. When invoking a benchmark using a scenario from the command line, the difference here is that instead of passing the name of the Gradle task, I will pass another extra parameter called scenario file, and I will pass the name of this file, right? So yeah, quite straightforward as well. So maybe you can see a demo on how we have this kind of thing running here. Let me go to my command line because I run so many benchmarks here. Yeah, I won't run this benchmark by myself, right? And why not? The reason is quite simple. The reason is that benchmarks are a very heavy, very resource consuming thing, right? When running benchmarks, usually our MacBooks kind of ignite all the funds and so on and pretend to fly. Yeah, so I don't want kind of to degrade the experience of this talk running a benchmark here, but I run one before our talk. And this is more or less how it works. Here I am kind of running a benchmark for the Android Sunflower project. And yes, I am running here in particular the assemble debug task using 4 warm-up builds, 15 measure builds, and then the Gradle Profiler will instrument the build with the default Gradle, and yes, running cleanups before every build and so on. So I have this kind of thing here. Amazing, right? Amazing. I'm running all these builds, and in the end, I have here this particular HTML file. So let's have a look on how this HTML file looks like. So yes, file not found. Oh my God, this is the risk of live thing, right? Maybe I move this file somewhere else. I need to find a file quickly. Oh my God. No, it's not here. No, I want my benchmarks again. Oh, here I have my tool. No worries, people. I have benchmarks for you. How the benchmark looks like. Let me find this file here using Finder really quickly. Yes, so I have here, I have here, I have here, I have here. Oops, huge. Okay, this one. Oh, there is something wrong with my benchmark. Oh my God, what I did. Maybe I corrupted this benchmark. Let me open it on Chrome here. Okay, here I have my benchmark. So the benchmark HTML report will be more or less like this. So I see here my 15 builds. I see that the build times are tracked using this fancy line. I have animations. It's quite fun. Yes, and the funny part is that this kind of report is a very, very new feature of Gradle Profiler. It's available only for the latest version of the tool, namely 0.15. Before this version, the benchmark file was a bit different, but also nice, right? And we have not only the chart, we have here the statistical measures as well, pretty much the mean of these results, the percentiles, the median, which which is pretty much a statistical measure, standard deviation, and the iterations that we had, right? So yes, live demos, right? Not only I can also see the CSV, I also have the CSV file with these results, namely with the iterations, right, that were run, and also some other meta information. So yeah, cool. I'm still representing here, right? Gradle Profiler is this. So the tool is quite simple, right? Here we won't kind of super drill down on how to define this kind of scenarios, because the scenarios are particular to each project. So for sure, one will like to benchmark the app assemble the bug task, but eventually what we want is eventually to benchmark a particular a build for a particular flavor or for some testing tasks, I don't know. So yes, scenarios can go kind of to the to the infinite if you want, and by looking into the documentation we can figure out all the possibilities that we have. My talk now will go to another place, because we need to do more than just run benchmarks. We need to figure out how to use science to evaluate the measurements. So here I have the results of 2 benchmarks, pretty much the data that we will get inside the CSV file generated by Gradle Profiler. So I have benchmark 1, benchmark 2. I have the values and I have the charts, right? By looking on these charts, it's really, really hard to tell that, okay, benchmark 2 eventually has lower values, right? Yes, so these measures are not enough. Luckily, we can go to other statistical measures like the mean and the standard deviation, right? And here, by comparing the means, we can see that the average from the benchmarked builds, the measure builds, better than that, the measure builds from benchmark 2 is greater than the mean of the measure builds of benchmark 1, right? Yeah, this is the results that we got. But not only that, we need to acknowledge as well that when evaluating this kind of thing, averages eventually are wrong, right? Here we have a blog post from a very famous data science blog, which discuss around this topic, right? Which is quite straightforward for people from data science. But I have only one quote here to share with you, and I will read this. So first, it is common to any data set for there to be outliers. These are often best seen in the graph, where most of the data points cluster around a narrow line, then one or a few data points are off in a never land. If we go to our chart, we can see that these particular outliers are present, and these measures are pretty much driving the results of the second benchmark. These kind of outliers are captured by the standard deviation metric, and we can see that the standard deviation for the second benchmark is way greater than the standard deviation for the first one. So we can't just say that the second benchmark performed worse than the first one, because we cannot just go with the mean. We need to take into account the standard deviation as well, the outliers as well. So we need to do something more, right? This is the reason why we will need a bit of data science to make the most of this kind of results. Because when doing some kind of experiment to our build, what we are trying to do is pretty much, I don't know, figure out a better Dagger setup using less annotations, or eventually applying some kind of Gradle flags that are new on the Android Gradle plugin, or eventually applying some other Gradle flags that are new with the Gradle distribution itself. But these kind of things eventually bring also consequences. We need to change code. We need to do breaking changes, you know? So we need to make sure that these changes will bring value, will make our build faster. And we need to have these in a very robust way. So yes, let's figure out how to do it with data science. From my university days, I had this class called Statistical Inference. And here we have a very, very fancy chart on how, on the overall idea on how statistical inference works, right? Lovely. I don't know if all of you are also from the mathematical background like me, but yeah, lovely stuff, right? Luckily, to understand this, we will rely on two friends here, namely Alice and Bob. Alice is the tech lead for an Android team, and Bob is an engineer. Bob wants to pretty much kill some annotations and figure out that eventually KPT will run less stuff, therefore the build will improve, right? But he wants to do some kind of proof of concept because he can't just go there and change all the annotations across a multi-thousand, hundred projects, you know, it's not feasible. So yes, Bob opened his pull request and he wants to make sure that, okay, I am in the right track here, right? But he doesn't know how. So he goes to Alice and presents his initiative. And the first thing that Alice will ask him is pretty much if he run the benchmarks using Gradle Profiler, right? Both for the pull request branch he has and also for the master branch, right? Okay, Bob will make this kind of sad face and he will acknowledge that he did the benchmarks, but he is not so sure on how to demonstrate that we have an improvement. And luckily, Alice is a former mathematician, so she will help. And in order to start help Bob, Alice will start explaining what are statistical hypotheses, right? Namely the null hypothesis and the alternative hypothesis, right? Bob will acknowledge that he missed that class. And yeah, so Alice will need to do something better and she will explain the hypothesis testing more or less in plain English, right? And what Alice will tell Bob is that the null hypothesis is pretty much what is our status quo right now. If you prefer, in terms of code, what we have in the base branch or in the master branch, right? On the other hand, the alternative hypothesis is what I am trying to demonstrate, right? The null hypothesis is also has a nickname. It's called 80, while the alternative hypothesis is called 80A, right? Then Alice will go next and pretty much explain the concept of statistical significance, right? Which is pretty much the probability of observe the sample driven by a particular probability analysis, right? Yeah, Bobby probably missed that class as well, which means that Alice will need to make this concept a bit simpler in order to allow Bob to understand. And then Alice will frame here this example. Your modifications will mean real improvements if I execute 100 runs of app assemble debug, and I see an execution faster than the average for 95 of them, at least, right? So since we can't guarantee that all the runs will have pretty much the best performance because all the things that can happen while we are building, right? We can just open Slack when we are building and then our computer can freeze, something like that. So yes, at least For 95% of my builds, I want to see an improvement. Then I can consider that I have an improvement. This means that my threshold for wrong results is 5% of my observed runs, right? This is significance level. Simple as that. Okay, going forward, Alice will explain the law of big numbers, lovely stuff, lovely mathematical formulas and so on, because you can have different distribution probability functions and so on. Yeah, Bobby is not that engaged at this point of time, but the concept is really, really simple, because the function that will drive the probability model is dependent on the size of the sample, or if you prefer, on how many measured builds we have in our benchmark, right? Since we have eventually for a large project, a really, really, really slow build, we won't be able to run hundreds, eventually thousands of builds for the particular app assemble the bug task. We will run a couple of them, maybe 15, 20, 25, something like that, which means that the distribution, the probability function that will drive the analysis will be the t-student function, the t-student distribution, not the normal distribution, right? In the end, both functions have, that very same shape that we are kind of tired to see from all the analysis about COVID, right? But the fundamentals behind them are different. Cool. Next thing that Alice will explain to Bob is the concept of the p-value, right? Probably one of the most important things that we need to get from this talk, right? P-value is the probability of an error type 1 in the hypothesis testing. Yeah, what that means, right? What that means. The p-value is pretty much the area under the curve driven by the distribution function, and given that I managed to calculate the critical value. When doing this kind of analysis in my university days, I used to have this kind of table, printed table, in order to do the tests, you know. Yeah, but in the end, the concept is really, really simple. P-value is the probability of observing a false positive, right? And if you prefer, if I run a particular Gradle task, let's say app assemble the bug 100 times, then eventually the probability model will tell me that, okay, from 100 runs, 3 runs will be false positives, which means that I am getting the wrong result, but I will actually thinking that the result is right? So p-value is this, the probability of the false positive, right? Yes, and going forward, bear with me, I am almost there. Alice will explain the notion of the critical value and what actually the tail analysis means, right? Eventually, when comparing the means between the null hypothesis and the alternative hypothesis, we need to figure out which tail of the distribution curve we are looking into, right? Yeah, Bobby is not that super engaged in the explanation at all, but in the end, what happens here is quite simple. If we want faster builds driven the implementation that we are trying to push into the master branch, what we need to have is the following: the observed mean average, the observed mean in the benchmark after my modifications has to be smaller, not lower, sorry, has to be smaller than the value that for the mean that we have before. So I will run 2 benchmarks, one for the pull request modifications and another one for the brace branch. And I want the mean to be smaller, statistically smaller, right? I want to take in account the probability analysis, not only the absolute value of the means, right? So which means that the analysis that we want is a left tail analysis. So yeah, we have everything in place, right? Alice, Bob was kind of, you know, just joking and pretty much making fun during the explanation. And Bob will acknowledge that we don't have the actual value for the mean of all possible builds of assemble debug. So we will compare means between two different samples. And in statistics, this is called pretty much something like a Parrot test, right? We are not comparing the mean of a sample against the mean of the population. We are comparing two means from two different individuals. Yeah, so right now, Bob is kind of wondering if he will need to do all the calculations by hand, like in the university days, right? And yeah, Alice will pretty much take some revenge on him right now. But in the end, we have tools. We have tools to drive this kind of analysis, right? Here we have a tool, lovely tool. Pretty much that tool that I used to use in my university days. But we have modern stuff as well, like the SciPy framework from Python. So yeah, given all of that, we can finally realize how we can make the most of the data generated by Gradle Profiler benchmarks. And how do we do that? First thing, we will pick up a Gradle task, right? Then we will pretty much run two benchmarks. One for the base branch that we have and another for the pull request branch with the changes that we are pretty much trying to prove, right? These two benchmarks will fulfill the input for a Parrot test that we will use the tStudent function and we'll do a left-tailed analysis because we want that the mean for the modifications to be smaller than the mean of the status quo. In order, the output of the left-tailed parity test will be the p-value, the probability of observe a false positive. We will compare this with the threshold, with the amount of wrong results that I can accept in order to have a strong statistical evidence. So we will compare these two values, these two numbers, and if the p-value is smaller than the significance level, then I have a strong statistical evidence that my build has improved. Otherwise, I don't. And most likely, my build is actually worse than before. Woof, yeah. We are there, people. We figured out actually how to compare in a very robust way two benchmarks generated by Gradle Profiler, right? So time to see an example, right? The examples of this talk are hosted in this particular repository, right? I still have some minutes. My running environment, because we need to define the running environment, is pretty much this MacBook Pro machine using this particular Gradle properties in my .gradle/gradle.properties file, right? Oh yeah, let's do this. How do we pretty much actually, I need to define my experiment, right? I skip it here one slide. My target here will be the SDK search project from Jake Wharton, right? Pretty much a Kotlin multi-platform project. What I want to learn is the following. Since I know that this project builds correctly with different JDKs, for instance, JDK 11 and JDK 8, I want to learn if by just switching the JDK, if I can get a faster build. Because JDK 11 has better garbage collection, has, I don't know, better optimizations or whatever, right? I can ask, won't it be wonderful if just switching JDKs we have a 2% faster build? I think it is. So yes, How can we figure out that? So in order to do that, I will define a scenario file, right? And I will define my execution using 4 warm-up builds and 15 measure builds. I already run this benchmark. I can run here because it takes almost an hour to run, but I have these results here in this spreadsheet. Oh my God, you have data science, so you need to have a spreadsheet, right? So yes, but you can go to the GitHub repository and see the CSV files there. So I have the CSV files here side by side in this CSV, and I am interested particularly in the measure builds, right? Not in the warm-up builds, but in the measure builds. So I will pretty much copy these measure builds here, and I will paste here in my calculator. Lovely. I already know what I am looking for when using this kind of tool. And this was the reason why we went through the whole concepts of data science, because I want to do a left-tailed analysis. I want to include the outliers. I want my significance level to be 5%. And and this kind of things here is the effect size is pretty much what I need to do if the sample is not following so well the normality condition, which means that it has that particular that particular sin curve that we saw every day from the COVID news. Okay, I have the values here because I already had the values here pasted. I can calculate. Let me just figure out. Okay, I can calculate and I can see the results. So I can see that my sample is potentially symmetrical, right? I can see that I have some kind of outliers. But the most important part here is the conclusion. And in the conclusion here, we can see that P-value is greater than the significance level. Therefore, the null hypothesis is accepted. What this means? What does this mean? Sorry. This means that actually my build is not improving with JDK 11. Actually, my building is getting worse with JDK 11, right? And yes, by just looking these numbers here, I think that it would be really, really hard to figure out this. By looking just to the simple means, 22 here, 23 here, or actually 200,000 whatever here, and the same here. Okay, so it's not straightforward, no, with this particular standard deviation. But with the tool, we can make the most of the result, right? Amazing stuff. Amazing. So Alice can help us with the conclusion here. That p-value is greater than the significance level, as we saw. Therefore, we can't accept the alternative hypothesis, which means that I don't have evidence, strong statistical evidence that builds are faster with JDK 11, right? Luckily, I am not a guy that likes to copy and pasting, so I wrote a tool to run these kind of things for me. I built this tool lives in this particular GitHub repository. I built it with Python on top of NumPy and SumPy and so on. And this tool is already published in PyPy as well. You can just install with pip if you are use it to Python. It's quite straightforward. And this tool does pretty much the same thing. So it will pretty much take the 2 CSV files generated by Gradle Profiler. It will input these 2 files in the Parrot t-test, left-tailed. We'll compare with the significance level, which normally is 5%. And we'll drive the conclusion that since the p-value is greater than the significance level, we don't have strong statistical evidence of improvements, right? Amazing. Another example here just to finish my talk because I am out of time. IOSCAT from Google, and here I just want to do a Gradle bump. I ran this benchmark some time ago, but the idea here is to pretty much figure out if bumping my tooling, if I get a faster build, right? This is what my alternative hypothesis is, pretty much the bump. I define my scenario. I will say that my execution consists of 4 warm-up builds and 15 measure builds. Here I have my Git diff. Here I have the CSV file for the outdated scenario, the outdated benchmark, pretty much the status quo. Here I have the CSV file for the new version of Gradle and AGP, right? Pretty much the modifications. I will input this on my tool and I figure out that, yeah, we have really, really strong statistical evidence that we have improvements because the p-value is almost 0, right? Which means that, okay, the mean dropped a lot, is almost, I don't know, twice fast than before. So yeah, okay, just looking to the mean and to the standard deviation, we could go with confidence, but we could still leverage this tool in order to make sense of the results. Yes, so we finally know how to benchmark 2 builds, actually how to benchmark 1 task with 2 benchmarks and how to make the most of this kind of results. Final remarks here to finish: play around this tool, design your experiments locally, run these experiments locally, and most important, take your decisions based on the data that you have, based in your context, in your project, in your reality, in your build machine, in everything, not in the subreddits or tweets out there, right? This guy is me. My name is Ubiratan. I am from Brazil. Here you have my Twitter handle, my website. These slides are already online on my speaker deck, which is available in this QR code. I really, really appreciate all the time and that that I had here. Really happy to be here with you today. If you have some questions, go to Slack. Yeah, thank you very much. See you.
Thank you, Ubiratan. That was awesome.
I can stop share here?
Yeah.
Okay.
Hey, folks. As we said, you can head over to the Slack channel if you have any other questions or want to have an extended discussion. And I believe the closing remarks will be happening in about 10-15 minutes. Thank you so much for joining us today. Can't wait to actually see you in the future back in person again.
I hope so.
I know. We'll get there.
See you, people. Have a good weekend. Bye-bye.